Hello everyone, you're watching TheMathsGeek. In today's video, we're going to be solving two more problems from the IOQM. This is a continuation to my previous video. So without further ado, let's dive into it. Problem number one is a summation problem. Now there's only one key insight into this problem which I will give you as a hint. So let me just write the hint down and all of you can try this out. So the hint is to relate k square plus k and 2k plus 1, or more precisely relate k and k plus 1 to 2k plus 1, expressing it as a difference of two squares. Okay, that is the key element to solve this problem. So let's dive right into the solution. So a difference of two squares. So the thing which works here is, of course, to notice that k plus 1 whole square minus k square is 2k plus 1, and also to notice that the denominator actually breaks down into k times k plus 1 whole square. So let's go into it. K plus 1 whole square minus k square. Now I'm just going to write this as k square times k plus 1 whole square by the properties of exponents, and this is given to be 0.9999. Okay, let's forget the 0.9999 bit for now and continue. So now we just distribute the fractions k plus 1 whole square over k square times k plus 1 whole square. All that remains from there is 1 over k square, and from the other part all that remains is this 1 over k plus 1 whole square. So now we've got our sum into a much more easier form which we can tackle with. And this is in fact a telescoping sum. Let me show you what I mean by that. So if we put in k is equal to 1, we get this 1 over 1 square minus 1 over 2 square. Then at k is equal to 2, we get this. And then goes on till 1 over n square minus 1 over n plus 1 whole square. Alright, so now one thing you have to know, one thing you can notice is that this negative 1 over 2 square cancels with the plus 1 over 2 square. The negative 1 over 3 square cancels with the plus 1 over 3 square in the next term, and so on. So all the terms cancel out till this negative, till this plus, pardon, 1 over n square minus 1 over n plus 1 whole square. And the only terms left are your first 1 over 1 square and the last minus 1 over n plus 1 whole square. So this is actually going to be 1 minus 1 over n plus 1 whole square. Now you see why we call it a telescoping sum. Just the first and last sum remain. All the thing in the middle gets broken, gets is of no use to us, and gets shrunk at the end. Okay, so now let's solve this very easily. Let's finish the problem. Now we figured out that this sum is 1 minus 1 over n plus 1 whole square, and so let's just equate that to 0.9999, and I'm gonna write that as 999 over 10 power 4, as I obviously have to find an integer value of n, so why not write the denominator squares. Okay, and now this gives me 1 over n plus 1 square to be, when I take it to the other side, I am left with 1 over 10 power 4. Now I reciprocate and square root both sides, which gives me n plus 1 is 10 square 100. Therefore, my n value must be 99, which finishes off our first problem. Alright, so let's move on to question number 2, a geometry cum algebra question. So let ABCD be a rectangle in which AB plus BC plus CD is 20 and AE is 9, where E is the midpoint of side BC. Find the area of rectangle ABCD. Alright, so let's just draw rectangle here. Okay, A. B, C, D. Now let's say this is my E, the midpoint. This is 9. Now one thing you know that the opposite sides of a rectangle are equal, so AB is equal to CD and let them just be X. And again by this equation, since ABCD, we can figure out that BC is going to be 20 minus AB plus CD, which is 20 minus 2X. And since BE is just the half of BC, going to be half of 20 minus 2x, which is 10 minus 2x. All right. Yep. So b equals ec equals to 10 minus x. Sorry about that. So 10 minus x. Okay. Now one more thing to remember is that every angle in a rectangle is a right angle 90 degrees. So now good old Pythagoras comes to help. In triangle ABE, we use Pythagoras or the Go-Go theorem. I hope someone gets the reference. Okay, so AB square plus BE square equals AE square, which gives x square plus 10 minus x square as 9 square. Now using the A minus B whole square formula, just write that down like A square minus 2AB plus B square. And then simplifying, we get 2x square minus 20x. So 100 equals 81. Bringing the 81 to the LHS, we get this final equation to solve. Alright, so we have arrived at this equation in x, and now we want to find the area. Now there are two approaches from this point. One is the rather more elegant approach, and the other is a laborious approach. Let's look at the elegant approach first. So what's the area in terms of the sides for a rectangle? It's yes, length times breadth, AB times BC over here, so x times 20 minus 2x. Now this is just going to be 20x minus 2x square. Now notice we've got something very similar in our equation involving x. We've just got that's right, additive inverse of that. So we can just bring it out to the other side from this equation. We can simply write that 20x minus 2x square is just 19, and this is the area of the rectangle, 19 square units. Pretty good, hey? Okay, so this was an elegant approach from where we just found the area in terms of sides and related it. Yes, the other one is also kind of the same, but for the other one, we just solve for x from this equation, get two values. So let's use our friend, the quadratic formula. Minus b minus 20 plus 20 plus or minus square root of b square, 20 square 400 minus 4ac, 4 times 19 times 2 all over 2a, 4. Okay, so now with the multiplication stuff is just 152. So we have left 248, 4. Now notice that this will of course yield two values for x, but we know that x is the side length of a polygon, and therefore it should be greater than 0. So we just take the positive sign and we write down x as, well, let us simplify. 20 of 4 is 5, and root 248 is root 31 into 8, which is 2 root 62. So root 62 all over 2. Alright, so we found x. Now let's find 20 minus 2x to get the area. Okay, Alright, so the only part left is to finish this, and now we find 20 minus 2x, which is, well, this is actually gonna be, let's see, 20 minus 2 times 5 is just 10, and you just add a root 62. So that's just gonna be what? 10, yeah, 10 minus root 62. Okay, this is good news for us. So let's just write that the area is x times 20 minus 2x. Okay, for the 2x stuff, 2 times 5 plus 2, 2 times 5, just 10. The 2's get cancelled, so root 62, hope that's clear. So x was 5 plus root 62 over 2. Okay, so that's going to be 5 plus 2 times 10 minus root 62. Now I'm just going to distribute 2 in a first fraction as the common denominator. That's going to give me 10 plus root 62 times 10 minus root 62. That's right. That's a difference of 2 squares. So that's going to just be a square, which is 10 square minus root 62 whole square. That's just 62. So that's just going to be half times 100 minus 62, half of 38, and that's just 19, and we get the same answer as before. Obviously, we will. So, yeah, this was a bit more of a laborious approach, shall I say, and I like the elegant approach more. I know some people may prefer the laborious method, but that's just me. Okay, so in the other videos, we're going to be discussing solutions to more IOQM problems, and I will probably post videos on more number theory topics like prime numbers, theorems related to infinitude of prime numbers, something about twin primes, perfect numbers, Mersenne primes, and yeah, that's all for today. Thank you. This is Gauraj Kapoor, the Maths Geek, signing off.